Chemistry Solutions booklet code B. Question number 61. The total number of lone pairs of electrons present in I3 minus ion is, in I3 minus, I has sp3d hybridization and linear shape. Here this iodine has 3 lone pair of electrons and this iodine has 3 lone pair of electrons, and we have 3 lone pair of electrons which are not involved in any bond formation. So totally we have 9 lone pair of electrons. So in the given 4 options, option 1 is correct. Question number 62. Which of the following salts in the most basic in aqueous solution? Let's see, after hydrolysis of the given salts, what are we getting? Here FeCl3 is giving ferric hydroxide and HCl. As we know that ferric hydroxide is a weak base and HCl is a strong acid. So the aqueous solution of FeCl3 is strong acid. Now let's see for lead acetate. Lead acetate giving weak base and weak acid, which are nothing but lead hydroxide and acetic acid. And now aluminum cyanide, after hydrolysis we are getting aluminum hydroxide, which is very weak base, and HCN, which is also weak acid. And here potassium acetate, after hydrolysis we are getting acetic acid, which is very weak acid, and potassium hydroxide, which is strong base. So as a result the solution becomes strong basic in nature. So in the given 4 options, option 4 is correct. Question number 63. Phenol reacts with methyl chloroformate in the presence of sodium hydroxide to form product A. A reacts with Br2 to form product B. A and B are respectively. Question number 63. Solution. So here phenol, when reacts with base like OH minus, it giving phenoxide ion. This phenoxide ion acts as a nucleophile. So nucleophile attack takes place here and this will go out. So as a result we are getting this compound. Here this group acts as a ortho and para directing group. So we will get the electrophilic substitution at the ortho and para position. Here what is the electrophile here? Br2 is giving electrophile, that is nothing but Br plus. That electrophile is going to substitute the ortho and para positions. As a result we will get the 2 compounds. Those are nothing but these only. So in the given 4 options, so this one and this one is there. So the first answer has these 2 options. So option 1 is the correct answer. Question number 64. The increasing order of basicity of the following compound is, in the given 4 options, option 1 is correct. Here this is the order of increasing basicity of the given compounds, and this last compound has 2 resonating structures. As a result, these are the 2 resonating structures. As a result it has more basic character. And this given 2 compounds, as we know that tertiary amines has more basicity, that means greater than secondary, greater than primary amines. So this is secondary amine, this is primary amine. So secondary amines has the more basic than primary amines, and imides always has less basicity than primary, secondary and tertiary amines, because here we have the double bond. As a result it always puts the electrons from the nitrogen. As a result it does not easily give its electron pair. So this is the order for the given 4 compounds. Option 1 is correct. Question number 65. An alkali is titrated against an acid with methyl orange as indicator. Which of the following is a correct combination? In this titration we are using methyl orange indicator. So generally we use methyl orange indicator for the weak base and strong acid titrations. So in the given 4 options, the first option is correct, and the end point is yellow to pinkish red color changes takes place. That means weak base has yellow color, and for strong acid the methyl orange has pinkish red color. So option 1 is correct. Question number 66. The trans alkenes are formed by the reduction of alkynes with. In the given 4 options, the option 1 is correct because the sodium liquid NH3 gives trans alkenes from the alkynes, whereas thin HCl gives alkanes from alkynes, and H2 palladium carbon barium sulfide gives cis alkenes from alkynes, and fourth one cannot reduce the alkynes. So in the given 4 options, sodium liquid NH3 gives trans alkene, so it is the correct answer. Question number 67. The ratio of mass percentage of carbon and hydrogen of an organic compound CXHYOZ is 6:1. If one molecule of the above compound contains half as much oxygen as required to burn one molecule of compound CXHY completely to CO2 and H2O, the empirical formula of the compound CXHYOZ is, here the element and relative mass and relative moles and simplest whole number ratios are given. Let's see. Here let's take the element C and H, that means carbon and hydrogen, and their relative masses are, for carbon 6 and for hydrogen is 1, which is nothing but 6:1, which has given in the question paper. And here their relative mole ratios are 6/12, that means 6 by atomic number of carbon, and 1/1, that means 1 by atomic number of hydrogen. In this way you are getting 0.5 and 1. Later simplest whole number ratio gives 1 and 2. When we multiply this with 2, we are getting 1 and 2, which is nothing but here x value is 1 and y value is 2. And let's take the hydrocarbon like CXHY. The combustion of this hydrocarbon gives this equation, that is CXHY plus x plus y by 4 O2 gives xCO2 plus y by 2 H2O. Here the oxygen atoms are required for the combustion of this CXHY is 2 into x plus y by 4. So here I am saying about the oxygen atoms. So we have x plus y by 4 molecules, but we require x only oxygen atoms, that is x plus y by 4 into 2, that is what I have written here. So in this, half molecules or half atoms are required, or half atoms is equal to the Z value, that is given in the question paper. So 1/2 of 2 into x plus y by 4 is equal to Z value. This is given in the question paper. So Z value is equal, we are getting 1.5. So we have the x value is 1 and y value is 2 and z value is 1.5. So substitute in this equation or formula. So C1H2O 1.5 you are getting, that is CH2O 3/2. In the given options, the option 2 is the correct answer. Question number 68. Hydrogen peroxide oxidizes hexacyanoferrate 2 to hexacyanoferrate 3 in acidic medium, but reduces hexacyanoferrate 3 to hexacyanoferrate 2 in alkaline medium. The other products formed are respectively. Now let's see the reactions for the given compounds in acidic and basic medium. Here hexacyanoferrate 2 is reacting with H2O2 in presence of H plus and giving water molecules as a byproducts. And here this compound, that is nothing but hexacyanoferrate 3, is reacting with peroxides in presence of basic medium and giving these two compounds, that is water and oxygen. So in the given 4 options, the option 1 is correct, where H2O and H2O plus O2 are producing. So option 1 is correct. The major product formed in the following reaction is, now this is the given compound. Now let's see what happens in presence of acid when we heat it. Here H will come to here because it's acid. As a result, we will get the positive charge here, and here also we can expect another H. As a result, we can also have the positive charge here, and this further undergoes in presence of heat, will get the positive charge here, and plus alcohol, and here we'll get alcohol plus this one. So we have iodine minus here, that will come and attack here and here also. So as a result we are getting 3 products, and in the given 4 options, option 2 is the correct answer. Question number 17. How long should water be electrolyzed by passing through 100 amperes current so that the oxygen released can completely burn 27.66 grams of diboron? Atomic weight of boron is given 10.8 U. Here diboron, when reacts with 3 moles of oxygen, we are getting B2O3 plus 3 moles of H2O. So here how much diboron we are taking initially, let's see. So the diboron amount is given already in the question, that is 27.66 grams, and its molecular weight is 27.66 grams. So as a result we are getting 1 mole of B2H6, that is what we have initially. So 1 mole of B2H6 generally require 3 moles of oxygen, and this oxygen is produced by the electrolysis of water. If you want to get 3 moles of oxygen, how many moles of water molecules are required for hydrolysis? 6 moles of water is required. See, according to this equation, 6 moles of water is giving 3 moles of oxygen. This is what we require. That means here 6 moles of water means here oxygen, each oxygen has negative charge is equal to -2. So 6 into -2 means 12 negative charge, and here 0. Total number of electrons that are required to get 3 oxygen molecules from 6 water molecules is 12 electrons. If we consider in moles, 12 moles of electrons. Each mole of electron is nothing but Faraday, so we require 12 Faradays of the charge, and this 12 Faradays of the charge is also equal to I into T. I means amperes current, T means time taken for this one. So when we solve this equation, that means I is equal to 100, that is given in the question, and T is the time that we have to find. So when we do this calculations and convert it into hours, we will get T is equal to 3.2 hours. So answer will be 1. Question number 71. Which of the following lines correctly show the temperature dependence of equilibrium constant K for an exothermic reaction? This is the given graphical representation, and here the graphs are ln K versus 1 by Tk. So as we know that ln K is equal to ln A minus delta H naught by R in bracket 1 by T. Here the graph is this one and this one. So here we are getting the slope is minus delta H naught by R. So this is the negative slope. The answer should be C or D. And here we are taking exothermic process. So when we substitute the minus of delta H is minus delta H naught, because this is exothermic process, by we will write R. So we will get that is equal delta H naught by R. That means we are getting positive slope. So the answer must be B and A. So in the given 4 options, answer is A and B. Question number 72. At 518 degrees Celsius, the rate of decomposition of a sample of gaseous acetaldehyde initially at a pressure of 363 torr was 1.00 torr per second when 5% had reacted and 0.5 torr per second when 33% had reacted. The order of the reaction is, let's take the condition 1. For condition 1, rate is equal to rate constant into concentration of the acetaldehyde at time t, and the order with respect to acetaldehyde is x. Let's assume that. Now here the rate is given in the condition 1, that is 1, that is equal to K into the concentration or nothing but the pressure at time t is 5% reacted, that means 95% is there. That means 363 is the total pressure into 0.95 then this is the concentration at time t, that is called 1 is equal to K into 343.85 all to the power of x. The next condition 2, in this one the rate is already given, that is 0.5, that is equal to K into 363 into 0.67, because we have 33% is reacted, the left one is 0.67 only. So here 363 into 0.7 will have the concentration and all to the power of x. So 0.5 is equal to K into 243.21 all to the power of x, which is considered as a second equation, and the earlier one is considered as a one equation. So when we do 1 by 2, we will get the x is equal to 2. So the answer for this one is, it is the second order reaction, and the given 4 options, option 3 is correct, which is second order. Question number 73, glucose on prolonged heating with HI gives option 1 hexanoic acid, option 2 6-iodohexanol, option 3 N-hexane, option 4 1-hexene. The given 4 options, when we heat glucose with hydrogen iodide for long time, all the COH groups and CHO group are undergo reduction. So as a result we will get N-hexane. So in the given 4 options, option 4 is the correct answer. Question number 74, consider the following reaction and statements. Tetraamine dibromocobalt 3, when reacts with Br minus, it is giving triamine tribromocobalt plus NH3. So the given 4 options are, first one is 2 isomers are produced if the reactant complex ion is a cis isomer, and the second one is 2 isomers are produced if the reactant complex ion is a trans isomer, and the third one is only 1 isomer is produced if the reactant complex ion is a trans isomer, and the fourth one is only 1 isomer is produced if the reactant complex ion is a cis isomer. The correct statements are, now let us see, these are the 2 isomers of the given compound, that is cis and trans isomers. Now let us take the cis isomer, how it is undergoing substitution by the Br minus. Okay, now let us take the Br minus substitution takes place at this position. In that case we are getting facial isomer only. So, and when Br minus substitution is taking place at this position, we are getting another isomer, that is called as meridional isomer. That means from this cis compound we are getting 2 types of isomers. So that is the reason I have written here 2 isomers. And from the trans isomer we are getting only 1 isomer when we replace any one of the NH3 group by the Br minus. So that is nothing but this one. Here we are getting 1 isomer, this is nothing but meridional isomer. So totally we are getting 3 isomers, that is nothing but from the cis 2 isomers, from the trans 1 isomer. So in the given 4 options, option 4 is correct answer. Question number 75, the major product of the following reaction is, so this is the given compound and the reagents are nothing but here sodium OMe, that means methoxide, sodium methoxide. This acts as a strong base. So when the base O-methyl or methoxide comes to this hydrogen, it will take, and this bond will shift to here and this one will shift to like this. As a result we will get the double bond here, and here we will get another compound, that is ethanol. So in the given 4 options, option 4 is the correct answer. Question number 76, phenol on treatment with carbon dioxide in the presence of NaOH followed by acidification produces compound X as the major product. X on treatment with acetic anhydride in the presence of catalytic amount of H2SO4 produces. So here phenol when reacts with carbon dioxide in presence of sodium hydroxide, we will get orthohydroxy benzoic acid as the major product. And further this, when it reacts with acetic anhydride in presence of H2SO4, it gives acetyl salicic acid, which is also known as aspirin. In the given 4 options, option 3 is the correct answer. Question number 77. An aqueous solution contains an unknown concentration of Ba2 plus. When 50 ml of a 1 molar solution of Na2SO4 is added, barium sulfate just begins to precipitate. The final volume is 500 ml. The solubility product of barium sulfate is 1 into 10 to the power of minus 10. What is the original concentration of Ba2 plus? Here barium sulfate is a weak electrolyte, and that is the reason why we have equilibrium between products and reactant, or Ba2 plus and SO4 2 minus and BsSO4, that means barium sulfate. So the thing is, according to Le principle, when we add Ba2 plus containing strong electrolytes or sulfate containing strong electrolytes, the reaction will go backward direction. That is what happened when we add Na2SO4. This is giving 2 Na plus and sulfate ion minus. So we are adding this compound to this mixture. In that case, it is giving sulfate ions, it is also has sulfate ions. That means we are increasing the sulfate ion concentration. According to Le principle, the reaction will go backward direction. As a result, the final concentration of the sulfate ions in that solution is due to the strong electrolytes, not due to the barium sulfate and sodium sulfate, because it is due to the only the sodium sulfate, because this dissociation is suppressed by the presence of sulfate ions. So as a result, sulfate ion concentration that is produced by the barium sulfate is very less, and the sulfate ion that is produced by the sodium sulfate is very high. So finally we can say the sulfate ion concentration is nothing but the concentration of the sodium sulfate. So here concentration of the sulfate ions in the final solution is equal 50 ml of sodium sulfate into 1 molar of Na2SO4 by total volume after the addition of this sodium sulfate to the barium sulfate solution is 500. So that's we are getting 0.1 molar solution, molar for sulfate ions. And we know that barium sulfate concentration into barium plus 2 and SO4 2 minus product of this is 10 to the power of minus 10, that is given in the question, and Ba plus 2 is equal 10 to the power of minus 9 molar, and this is for 500 ml of solution, but we have taken 450 ml of solution only, because 50 ml of solution is related to the sodium sulfate. So we have 450 ml of solution regarding barium sulfate only. So concentration into 450, that is what we are going to find out the concentration of the barium 2 plus in 450 ml solution is equal 10 to the power minus 9 into 500 solution, 500 ml solution. So here we are getting C is equal 1.1 into 10 to the power minus 9 m. In the given 4 options, option 1 is correct. Question number 78. Which of the following compounds will be suitable for Zeldal method for nitrogen estimation? In the given 4 options, option 4 is the correct answer. Remaining 3 don't give Zeldal method. So option 4 is correct answer. Question number 79. When metal M is treated with sodium hydroxide, a white gelatinous precipitate X is obtained, which is soluble in excess of NaOH. Compound X, when heated strongly, gives an oxide which is used in the chromatography as an adsorbent. The metal M is, here let us take the X as aluminium. When it reacts with sodium hydroxide, it gives white PPT, that is nothing but aluminium hydroxide. So when we take excess of sodium hydroxide, it gives sodium meta-aluminate. That means aluminium hydroxide, this PPT is dissolving in sodium hydroxide. So the same aluminium hydroxide, which is nothing but considered as a X here, when we heat it, we are getting Al2O3, which is utilized as a adsorbent for chromatography technique. So in the given 4 options, option 1 is the correct answer. Question number 80. An aqueous solution contains 0.10 molar H2S and 0.20 molar HCl. If the equilibrium constant for the formation of HS minus from H2S is 1.0 into 10 to the power of minus 7, and that of S2 minus from HS minus ions is 1.2 into 10 to the power minus 13, then the concentration of S2 minus ions in aqueous solution is, Here H2S is a weak electrolyte, is nothing but weak acid, so it's giving 2H plus S minus 2. So this is the final reaction of the two reactions, that is H2S is giving HS minus plus H plus. In that case equilibrium constant value is Ka1, and the second one is HS minus is giving H plus and S minus 2, for that equilibrium constant value is Ka2. So here this is the final reaction of the two reactions, so we can take it as a equilibrium constant for this reaction is the product of individual reactions, that is Ka1 into Ka2. So here Ka1 is 1 into 10 to the power minus 7, which is given in the data, and to 1.2 into 10 to the power minus 13, this is also given in the data. That is equal to concentration of H plus and concentration of the S minus 2 by the H2S. Here H plus concentration we have to take for the strong electrolytes, that is nothing but for HCl concentration. So because this is a weak acid, so we cannot take the concentration of the H plus ions, that is nothing but 0.10, that is given in the question. So in the question for H2S concentration is given 0.10 and for HCl is given 0.20. So this is a strong electrolyte, strong acid. So when we go for strong electrolytes, strong acid and weak electrolytes, in these two H plus is a common ion. In that case we have to consider the concentration of the strong electrolytes. So these also giving, but the thing is the H2S is giving very less amount of H plus ions, that to be that dissociation is also decreases due to the common ion effect. So here finally we are getting only the H plus concentration for HCl. So we have to substitute the 0.20 and we are finding the S minus 2, and H2S is also given in the data. So in the finally we are getting the concentration of the S minus 2 is equal to 3 into 10 to the power minus 2. In the given 4 options, 4 is the correct answer. Question number 81. The recommended concentration of fluoride ion in drinking water is up to 1 ppm, as fluoride ion is required to make teeth enamel harder by converting calcium phosphate, calcium hydroxide, which is nothing but hydroxyapatite. To here hydroxyapatite is reacting with fluoride ion and giving fluoroapatite. So in the given 4 options, the option 1 is the correct answer. Question number 82. The compound that does not produce nitrogen gas by the thermal decomposition is. In the given 4 options, let's see first one, that is ammonium nitrate, that gives nitrogen gas when we heat it, and ammonium sulfate that gives, that means the option 2 gives ammonia gas, and the option 3, that is barium nitride, gives nitrogen gas, and fourth one is ammonium dichromate, that also gives nitrogen gas. That means in the given 4 options except 2, all are giving nitrogen gas, and the option 2, that means ammonium sulfate, is giving ammonia gas. So the correct option is second one. The predominant form of histamine present in human blood is, the pKa values given histidine is equal to 6.0. In the given 4 options, the option 2 is the correct one, because in the blood pH is 7.4. So this histamine is protonated at the NH2, that means the primary NH2. So in this all we will get protonated 1, means that second one is the correct answer. Question number 84. The oxidation states of chromium in the given complex. So we have 2 complexes. In these 2 complexes, let's see the chromium oxidation state. In the first one is it has +3 oxidation state, in the second one it has 0 oxidation state, and in the third one it has the +6 oxidation state. So the option 1 is the correct answer for the 84th question. 85. Which type of defect has the presence of cations in the interstitial sites? So in the given 4 options, the Frankel defect indicates the correct answer. So option 1 is the correct. The question number 86. The combustion of benzene gives CO2 and H2O, which are gaseous state and liquid state. Given that heat of combustion of benzene at constant volume is minus 3263.9 kilojoule per mole at 25 degrees centigrade. Heat of combustion in kilojoule per mole of benzene at constant pressure will be. That means in this question, at constant volume means the combustion volume at constant volume means the QV values are given. So we have to find out the QP values, and the temperature is given, and delta H value is also given. Now let's find out these values. Here the combustion of benzene reaction is given here. So it is, the reaction is this one, C6H6, which is in liquid state, is reacting with oxygen 15/2 in gaseous state and giving 6 CO2 gaseous state and 3 H2O liquid state. So here the thing is, there is a relation between delta H and delta E, that is this one, delta H is equal to delta E plus delta Ng RT. So delta H value that we have to find, delta E value is given in the question in the form of heat of the reaction at constant volume, that is nothing but delta E only. That value is -3263.9 plus delta Ng value, as we know that it is the sum of the product minus sum of the coefficients of the reactants, sum of the coefficient of the products minus sum of the coefficients of the reactants. So this value will get 6, delta Ng value will get 6 minus here 15/2, that means 12 minus 15/2 means 3/2. So delta Ng value is 3/2, and here we are getting minus, so minus 3/2 into R value 8.314, and temperature is 298 into 10 to the power of -3 is to convert the energies, that means heat values, heat energy values. So here delta H is equal to -3627.6 kilojoule per mole that we are getting in this process. And now let's see in the given options, option 2 is the correct answer. Question number 87, which of the following are Lewis acid? In the given 4 options, the option 2 is the correct answer, because BCl3 and AlCl3 can accept the lone pair of electrons. So we can say BCl3 and AlCl3 are the Lewis acid. So option 2 is the correct answer. Question number 88, which of the following compounds contain no covalent bonds or bond? So the given things are KCl, PH3, O2, B2H6 and H2SO4. As we know that KCl is a ionic compound, except this every other elements have or compounds have the covalent bonds. So in the given 4 options, the first option is the correct answer. Question number 89, for 1 molar aqueous solution of the following compounds, which one will show the highest freezing point? In the given 4 options, before going to the options, let me tell you what is the thing here. Freezing point is inversely proportional to the number of particles. That means if we have the less number of particles, that will have the highest freezing point. Now let's see in the given 4 options which has the less number of particles. So in the first option, it is giving 2 ions, one is complex ion, another one is Cl minus. In the second one, it doesn't give any ions. In the third one, it is giving 4 ions, 3 Cl minus and 1 complex ion. In the fourth one, it is giving 3 ions, one is complex ion, another one is 2 Cl minus ions. So in the 4 options, option 2 has the less number of particles. So this will have the more freezing point. So option 2 is the correct answer. Question number 90, according to molecular orbital theory, which of the following will not be a viable molecule? In the given 4 options, the option 1 has the bond order is equal to 0.5. For option 2, that means H2 minus has the bond order 0, and for option 3, He2 2 plus, that means helium 2 plus has the bond order is 1, and for fourth option, that is helium 2 plus has the bond order is 0.5. So wherever the bond order is 0, that molecule is not existed. So in the given 4 options, option 2 is the correct answer. Thank you for watching. I hope you understand the solutions of JEE Mains Chemistry Code B.